Okay guys, this is the 2015 sample paper and we're on question 2. 2015 sample paper question 2. So what we have here guys is, in a game of Scrabble, some players score points by making words from individual letter tiles and place them on a board. The points for each letter are written on the tile. To find the total score of a word, a player adds together the points of each tile used. In the game, Mara selects each of the 7 tiles and then makes the word jukebox. Find the total number of points Mara would score for above. So look, she gets 8 for the J, 1 for the U, 5 for the K, 1 for the E, 3 for the B, 1 for the O, 8 for the X, and when you add them all up together, you're going to get 27. Okay. Certain squares on the board can be placed to use to gain extra points. Part of one line of the board is shown. Mara place her words on the line with one letter in each adjacent box. Mara place her word on the board in a way that gives maximum possible score. Write in her word to show how she does this. Okay. So just remember one thing, guys. Okay. The word score. Scores for the letters are calculated first. So it's just a double letter score on both of them, okay? So double letter score on both. So here's what we're gonna do. So double letter score, we can write in jukebox this way, guys. Jokebbox. Jukebox, okay? And we can get a double letter score on both of them. So it'll be 8 here, 8 here. So these two 8s now turn into 16s, okay? Because they're worth double their letter score. So 16 here, 16 here. See, we want the J and the X to land on the double letter score, because the double letter scores, because they're worth 8 and they're worth 8 each, so they give you the maximum possible number. Then we have 1, 5, 1, 3, 1. So we add them all together. So we're going to have 16 plus 1 plus 5 plus 1 plus 3 plus 1 plus 16. And what we get is a 43. Score 43 for that, okay? Now, Mara also gets a bonus for using 50 points for using all her letters. Find the number of points Mara scores for this word. So she scored 43 plus her 50, which will get her 93 points. Okay, so that's good. So they're both double letter scores. Double letter score, double letter score. Okay, moving on. Write 3/8 as a decimal. Just get out the calculator. 3 divided by 8. What you're going to get here is 0.375. Now, what I recommend you do for this one is, what I did was I measured it, and what it turned out to be was 4 centimeters in the book. So I'm just going to adjust this until it's 4 centimeters. So I measured the side of it until it was 4 centimeters tall. So I'm just going to make it a bit bigger. And you can see now it's 4 centimeters tall. Now, 4 centimeters, I want to turn it into 8ths. So 4 centimeters divided by 8 will chop it up into 8ths, which is 0.5 of a centimeter. So if I count up in 0.5 of a centimeter each time, 1, 2, 3, 4, 5, 6, 7, 8. What I've done there is I've divided up into 8ths. Now I want 3/8 of the way, so 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So this is 3/8 here. Now what I can do is I can just shade it in with just shade it in like so. Actually, we need to bring it up a bit taller. Around there, that's 3/8 worth there. So we can see that that's it there. So that's 3/8 full right there. Okay. We're doing a fancy diagram. Now, represent 3/8 on the number line and 0.4 on the number line. So what I did is, once again, I got my ruler out and I measured what type of distance I'm dealing with here. So just moved all the way around, brought it over, and we saw what we're looking at here. So we can see that the number line in question, well, when I measured it, it was gone up in tens. So I'll just adjust this here. So when I measured it out, it was gone up in tenths. So what I'm going to do is divide it into tens. So that's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. So if I'm doing this, 0.1, 0.2, 0.3, 0.4, 0.5 is here. 0.6, 0.7, 0.8, 0.9, 0.10, 1. So I have it divvied out. Now, 3/8 is 0.375. Okay, and that's in between 0.3 and 0.4. So it's around here. 3/8 is around here. And 0.4 is here on the dot. So that's 0.4. Okay. How could the number line in C help you decide which of the two numbers is bigger, whether 3/8 is bigger than 0.4? Well, we know 0.4 is bigger than 3/8. Why is that, guys? Well, the reason is it's further to the right on the number line. The bigger number is further to the right on the number line. So there we go. Okay, so that helps us make it bigger. Now, in the diagram below, what we're asked for here is what fraction of row A is shaded. Well, look, this is row A here, and we can see that 3/4 of it is shaded. So that's 3 and 4. Okay, so 3/4 of row A is shaded. Next part, in the same diagram, what fraction of R is shaded? Well, here's a column R. As you can see with column R, it has 7 boxes, but 5 out of 7 of them are 5 of the 7 of them are shaded. Now, if we're to look at the overall picture, now I haven't been asked to look at the overall picture yet, but let's look at the overall picture. We can say everything in here. We can say that there's 15 blocks, so 5 by 3, 15 shaded, and once we do the 15 shaded, we then have 4 by 7, which is 28. 15 out of 28 are shaded. Okay, now look at this. Using the diagram or otherwise, calculate the result when the fractions of part 1 and part 2 are multiplied. So part 1 is 3 out of 4, part 2 is 5 out of 7. When you combine them together, we're going to make 15 out of 28. So that's how much of it. When we multiply this row with this column, we actually find out how much overall is shaded. So that's interesting to know. Tim claims that two fractions shown by the shading of the strips A and B below are the same. Is Tim correct? Give a reason for your answer. Well, answer for A, answer is no, they're not the same. They're not the same. Now, reason being, this A is 3 out of 5. B is 2 out of 3. Put them into the calculator, we find that 3/5 is 0.6 and 2 out of 3. Now, 2 out of 3 is not 0.6. See the dot above it? That actually means it's 0.666 or 0.67. So the reason being is 0.667 is a bigger number than 0.6. Hence, 2/3 is bigger than 3/5. Okay, that's that one done. Now we're going to move on with question 5. Dermot has €5,000. He would like to invest it for 2 years. A special savings account offering annual compound interest rate 4% if the money remains in the account for 2 years. Find the interest you'd earn in the first year. The interest is the extra money. Now, what you can do is, if you want to increase a number by 4%, you can multiply by 1.04. If you want to increase a number by 20%, you can increase it by 1.20. If you want to increase a number by 16%, you can increase it by 1.16. If you want to increase a number by 4.5%, it can be 1.045, 4.5%. So, in this question, if I want to increase a number I have €5,000. I'm going to increase that number by 4%. Going to multiply by 1.04. What I'm going to get is 5,200. But I have to take it away from 5,000 away from it because I want to find out how much interest I made, which is going to be €200. Tax of 41% is deducted from the interest earned. Find the tax on the interest. Okay, well it's 41%. So we're going to get, to find 41% of something, we can multiply the number by 0.41. 0.41 will find us 41%. So 200 multiplied by 0.41, and what we're going to get is €82. €82 is going to be taken away from us. So it's going to be 200 minus €82. 200 minus €82, which means that we're going to get €118. So the tax on the interest is €82. Okay? Sorry about that last part, guys. We actually answered the question. It's €82. Now, the amount of investment at the start of the second year. So we had €5,000 at the start of the first year. We made €200 interest, but then we had to pay tax of €82 on that. And what that's going to result in is 5,118. Okay, 5,118 is how much money we have. Find the total amount of dirhams investment at the end of the second year after the tax has been deducted from the interest. So at the start of the second year, we had 5,118. We then increase it by, remember we're increasing it by 4% for the second year. So increase it by 4%, and what we get is 5,118 multiplied by 1.04. And what we get is 5,022.72. 5,322.72. Okay. Now what we can do next, guys, is this. We can take away. We have to take away tax because we have to take away our initial amount because we want to find out how much interest we made. So minus 5,118. That's it there. So it's going to be 204.72. This €204.72. We're meant to add it. We're meant to add it on, but I'd like to find out what tax I paid. So remember, I'm paying tax at 41%. So I'm going to find out what 0.41 of my 204.72 is, because I have to pay tax on this money I'm meant to get. So I'm going to multiply that by 0.41. Write down what you're doing. 83. Now round this up to 94. 83.94. So that's how much tax I paid. I'm going to use the same formula as last time, except I'm going to do 5,118. That's how much I started off the second year with. I was meant to get 204.72 interest, but then I got deducted tax of 83.94. Put all these numbers into the calculator. And then take away my 83.94. And what we get is 5,238.78. 5,238.78. Okay, and that there is question 5. Now, we're going to look at next is question 6. Okay, so Samantha is estimating the number of people at a concert. Samantha counts 42 rows of seats. She estimates there are 19 people sitting on each row. But rounding each number to the nearest 10, find the total number of people sitting at the concert. So 52 is going to round off to 50. 19 is going to round off to 20. So we're going to 50 times 20. Is going to be 10,000 people. Okay. So, sorry, 1,000 people. Okay. Samantha estimates that the standing space is 600 meters squared. She estimates on average 2 people standing for each square meter. Use this to estimate the total number of people who are standing at the concert. So 2 people fit in to each square meter. We have 600 meters squared, okay, and 1 meter squared equals 2 people. So what does this tell you about 600 people? Okay, so what we're going to have is, so this is the amount of people who sit down. Now we're on the amount of people that are standing up. So we can take 600 times the amount of people. So multiply 2 people by 600, and you find that it can take 600 times the amount, which is 1,200 people. So we can take 1,000 people sitting and 1,200 people standing. A standing ticket costs €10 and a sitting ticket costs €15. Use your answers from A and B to estimate the total money you've paid for the concert. So what we can do here is we can do 1,000 sitting seats multiplied by 15 plus 1,200 multiplied by 10 and find out what our answer is. So it's going to be 15,000 plus 12,000, which is going to be €27,000. Okay, so that's question 6. Question 7 we're not doing. So now we're on to question 8. So what we have here is this. Question 8. Olivia cycled we do it like that. Okay. And scroll down. Now, Olivia cycled from her home to the shop. She cycled along a particular route and returned by the same route. The graph shows her distance from home along the route travelled from the time she left until the time she returned. Okay, so each block is worth 5. So each block is worth 5 minutes, okay? What's the distance from Olivia's home to the shop? So it says she cycles from home, she stops at the shop. If she stops at the shop, she's 5 kilometers away from home. How long did Olivia stay in the shop? She stayed 1, 2, 3 blocks worth, and each block is worth 5 minutes. So 3 multiplied by 5, 15 minutes. So she stayed for 15 minutes. Compare her speed on her trip to the shop with her speed on the way home. Now we need to know the speed equation. So speed equals distance divided by time. Now please remember that time has to be in metric system. It has to be in decimals or fraction mode, okay? So time is the important one here. So the distance we know on the way up is 5 kilometers. She travels 5 kilometers both times. So to the shop, speed to the shop, speed to the shop equals 5 kilometers. Now, how long did it take her to do this? It took how many blocks across? 1, 2, 3, 4. 4 blocks. 4 multiplied by 5 is 20 minutes. Now 20 minutes is not done properly, because we have to do 20. We have to change 20 into a fraction. It's 20 divided by 60, which is 1/3 of an hour. So you can do 50 divided by 20 over 60, or 5 divided by 1/3. Either way, you're going to get 15 kilometers per hour. The other way to do it is to mark off 5 like this with the button, and then divide it by. You can do it this way as well if you don't want to do the conversion. 0 and 20 minutes, and what you get here is 15 that way as well. So that speed to the shop is 15 kilometers an hour. Now speed going home is different. Speed going home is, she once again covers 5 kilometers home, but she does it in 2 blocks. So 5 kilometers, and she does it in 10 minutes. 10 minutes out of 60, or 5 divided by 1/6. Now to write this in the calculator, I could do it 2 ways. I could press the fraction button and the fraction button again. Okay, so it's going to be 5 divided by 10. Oh, wait a second. 10 over 60. which is 30. The best way I advise you do is 5 divided by 10 over 60, which you get you 30 kilometers an hour. Okay. Alright, 15 kilometers an hour, 30 kilometers an hour. Write a paragraph to describe her journey. Well, if we're going to describe her journey, let's do it over here. So, she travelled to the shop. She travelled 5 kilometers to the shop in 20 minutes. And she stayed in the shop for 15 minutes and then cycled home 5 kilometers in 10 minutes. So there you go. Is it done there? Now, question 9. Tina is standing beside a racetrack. A red car and a blue car are travelling in the same direction at steady speeds. I don't think we actually have to do this one, to knowledge. Okay, so a red car and a blue car are travelling in the same direction at steady speeds. A particular time in the red car has gone 70 meters beyond Tina at a speed of 20 meters per second. At the same instant, the blue car has gone 20 meters beyond Tina at a speed of 30. Complete the table below to show the distance between the red car and the blue car and Tina during the next 9 seconds. Well, what's going to happen next is we're going to keep adding on 20. So 110, 130, adding on 20s, 150, 170, 190, 210, 230, and 250. Because this here is the red car here. That's handy. Now we're going to do the blue car, which is going to be going 30 meters every second. So it's going to be 80, 110, 140, 170. We can see they're now equally far away from Tina. 200. Then the blue car overtakes the red car because it's going faster. 230, 260, 280. Okay. After how many seconds will both cars be the same distance from Tina? 5 seconds. Write down a formula to represent the distance between the red car and Tina for any given time. Clearly state what the meaning of each letter is that you use in the formula, right? So we call D equals, let's say D equals, so we're going to do this using our initial language, okay? So our initial language is at time 0, the red car is 70 meters away. So current distance away equals your initial distance plus your speed multiplied by time, because speed multiplied by time is how much extra distance you traveled. Okay, so if you look at this, our current distance, we'll call it D. Our initial distance is 70 meters. Our speed, how fast are we going in the red car? We're going 20. And let our time be T. Okay, so as an example, if T equals 1, it would be 70, we don't have to do this now, 20 times 1, and that will get you 90. If T equals 2, it'd be 70 plus 20 multiplied by 2 will get you 110. And you can see that that formula matches with your 2 points on your red value there. So that's how you know you're correct, okay? So look guys, the answer to that question is just this part here. 70 plus 20t. Now, have we done part C? Okay, next question. Write down a formula to represent the distance between the blue car and Tina for any given time. Well, look, it's going to be the same as the red formula here. So this is the formula for the this here is the formula for the red car. So I'll just change that to red. Now we're going to do the same thing for the blue car, except this time we're going to write it in blue. So its current distance d. Now what is the initial distance of the blue car away? The blue car is 20 meters away. How fast is the blue car going? Blue car is going 30, and the time is the same. So this here is going to be our formula for the blue car. Okay, so that's it there. Now, explain how you could use the formulas from C and D to verify the answer you gave in part B above. So part B was that the time they intersected each other was 5 seconds in. So what I suggest is when they hit each other at the same time, what you say is distance covered by blue equals distance covered by red. And remember, both formulas give you the distance covered. So we can say is 20 plus 30t ends up to be the same thing as, what's the other formula down here? 70 plus 20t. Now we can solve the t value from this using a linear equation. So we're going to bring the 70, bring the 20 to the left and 20t to the left and the 20 to the right. So you're going to get 30t minus 20t equals 70 minus 20. 10t equals 50. T equals 5. This is the same time that we were expecting. Okay. Now, finally, on the diagram below, draw graphs of the distance between the red car antenna and the blue car antenna over 9 seconds. So at the moment we have the first 9 seconds. So the 2 points I'm looking for the red car, it's a straight line. So 0.70 for the red, and you can see 9 seconds it's 250 away, 9 250. Then for the blue car I'm going to use 0.20, and then for the after 9 seconds the blue car is 280 meters away from Tina. So these are the only points I need. Okay, so I'm just going to highlight these points here and I'm going to draw them down. So cut, and then up here. So let's start off with the red one. So we're going to have 0.70. So that's the red car starting here. And then we're going to have so red car, then we're going to have 9 and 250. So 9 is here, and then 250 up. It's going to be here. And we can see we can put in our red line here. Okay, so that's our red line. Now we're going to do the blue line next, where blue is where does the blue car start? The blue car starts 20 meters in. And where does the blue car end? 280 meters. Up here. Going to join the blue line together. Like so. And call that the blue line. There we go there. Now, we can see where they intersect each other, the 2 points. You can hopefully see that's 5 seconds in. Might need to draw this again. 0.70 to 9 250. 250 is located here. That's 9 250, no bother. That's 9 280. Yep, and 0.20. Sorry guys, so this didn't quite link up as well as I would have liked. Now the reason for that is actually 290. The last one was plus 290, so I just made a quick mistake on that, and that would explain why none of the answers are wrong. Now just explain why this graph didn't turn out as well as I would have liked. So 290, excuse me. So I'll have to shift this graph one more up. Now we can see that the intersection is right. So you can see the point of intersection here, guys, between both lines is where basically the line, it's 5 seconds in and 170 centimeters is the point of intersection. So that's the next question. Explain your connection to answer B in the graphs F below. The point of intersection is 5 and 170, which means after 5 seconds both cars were 170 meters away. Okie dokes.